In this video, we're going to learn how to implement merge sort in Java using our parallel programming. So merge sort is a divide and conquer algorithm. It takes an array and divides it in two halves, and then it keeps dividing and then sorts those halves and then merges them together, and that's why it's called merge sort. So before we jump into coding merge sort, let's see how merge sort works. So we take in an array. Let's say this is an array of integers, so 5, 3, 2, 6, 1, and 7. This is an unsorted array. And what it does is it halves the array. So it splits this to be 5, 3, and 2, and 6, 1, 7. Then what happens is that it splits it again. So this becomes 5 and 3, and this becomes 2. And this becomes 6 and 1, and this becomes 7. And then finally, we split up 5 and 3. We can't split up 2, it's done. This gets split up as 6 and 1, and 7 can't be split anymore. So what occurs is these merge back. So this merge back and in the order. So it goes 3 and 5. And then this can merge in. So it becomes 2, 3, 5. Might have not saved enough room for myself. So these two get merged in. This becomes 1 and 6. We're sorting it, remember? 7 gets merged in. So this becomes 1, 6, and 7. And finally, these two get merged in to make our resulting array of 1, 2, 3, 4, 5, 6, 7. So this is an example of merge sort. So let's first implement merge sort without parallel programming. So I have a new project here called parallel merge sort, and I'm going to implement our merge sort algorithm. So let's first make the merge sort algorithm without doing any multi-threading or parallel program. So I'm going to make a new Java class. I'm going to call this merge sort. And this is going to do the exact example that we just wrote out together. So we're going to have a main method with an unsorted array, and then we're going to sort that array using our merge sort algorithm. So let's first write our main method. I'm doing main and then a tab, and that auto generates our main method for us. And I'm going to declare our integer array. So int bracket array, and I'm going to use an array initializer. So curly bracket, and I'm going to put in the numbers that we did earlier. So that's 5, 3, 2, 6, 1, 7, semicolon. So we're going to have to make a method that sorts our array. Let's just leave a comment here where we're going to say we're going to call our merge sort, and let's write our output so that we can see when our array gets sorted that it's correct. So for int a in array. This is a for each loop. So I'm saying for every integer in the array. So every integer in this array, outprint something. And I'm going to write system.out.print line a. So if we run this code right now, we're going to get 5, 3, 2, 6, 1, 7 outprinted on each separate line. Right click, run. There we go. 5, 3, 2, 6, 1, 7. So now we need to implement our merge sort method. So let's make a method called merge sort. It will implement the algorithm that we just went over, and the result will be a sorted array. So public static void merge sort. We pass in the array that we want to sort. So int bracket array. We are going to be modifying this array variable, so it will automatically be modified here. We do not need to return the newly sorted array. So merge sort, as you might be able to tell, and we're going to go back to our image. So if you can tell from here, our merge sort is kind of a recursive function, right? We keep splitting up our array until the size is 1. And when the size is 1, we are done. We don't need to go any further. So we split up our array into 2 separate parts, and when the size is 1, we merge them together. So if our array is greater than 1, we need to split our array in half and then call merge sort for the first half of our array and the second half of our array. If array.length is greater than 1, we need to declare a new array that is half the size. And it has to be our first half and our second half, because remember, it can be an odd number. So if our array was 3, we need to make sure that when we divide it by 2, that one part of it has the size of 1 and the other part has the size of 2. So let's find the midpoint for our array. So let's call this int mid, and this will equal array.length divided by 2. So our first half would just have the length of mid, and our second half is going to have what is the remainder for mid. So we can declare 2 arrays, one that's called first half and the other that is called second half. So int first half equals new int mid. And now we want to copy our array over to our first half. So we want to copy all those values over. We can use something called system.arrayCopy. It takes in the source object, which was this case is array, the starting index point, so that's going to be 0, and then the array that it's being written to, so first half, and then the starting position for the destination array, so that's 0, and then the total length, in this case, will be mid. So this will copy from 0 to mid from array over to first half. Then what we want to do is called merge sort for our first half. So merge sort first half. We also have a second half that needs to be sorted. So right above our merge sort for our first half, let's say int second half equals now the remainder that we have. So this will be new int the array's length minus mid. So in the case for our array length being 3 divided by 2 is 1.5, but this is an integer, so it's 1. So our first half has the size of 1, and our second half will have the size of 2. Same exact logic here. So we are declaring our second half. Now we need to copy from our array over to the second half. System.arrayCopy array. The starting position for our array in this case is going to be at mid. Then our second half, which is the destination, its starting position, which is still 0, and then its total length, which was array.length minus mid. So array.length minus mid. And now we have to make sure that we call merge sort for our second half. So when this code gets ran, we get our merge sort for our first half, the merge sort for our second half, but then we need to merge them together. If we go back, they get split up. They keep getting split up, but then 5 and 3 get merged together, and then 2 gets merged together. So once these lines of code get executed, we need to merge. So we're going to make a function called merge. So I'm going to write a comment here and say merge, which will merge our first half with the second half into our array. So this is going to be a lot of code. So what I'm going to do is make another method and call it merge. So this will be public static void merge, and it will pass in our first half of the array, the second half of our array, and then our overall array that we're updating. Let's call this int first half, int second half, and int array. So what we're going to do is keep track of the current index for our first half, the current index for our second half, and the current index for our overall array. So we're going to make an int and call it current index first. It's defaulting to 0. Then int current index second, which defaults to 0. And then int current index array and set it to 0. And we're going to loop through our first half and our second half, compare the two, and place the sorted item in our array. So while current index first is less than the first half dot length, and current index second is less than our second half's dot length, we're going to compare the two. So we're going to keep incrementing our current index of first, our current index second, as well as our current index of our overall array. And we're just making sure that we're not going to do any array index out of bounds exceptions. So we're going to make sure that we're staying within the index of both our arrays. So pay attention that your current index first is comparing to your first half of the array length, and your current index second is comparing to your second half of the array length. So if our first halves at current index first is less than our second half at current index second, then we're going to place the first half's item first in the array. Otherwise, we're going to place the second half items in the array. We're sorting from smallest to largest. So array, so then array, the current index of our array will equal the first half's current index first. And then we need to increment the current index of our array and the current index for first. If that's not the case, then we need to place the second half in our array and increment the other way. So otherwise, array, current index of our array equals the second half's current index second. And our current index plus plus current index second plus plus. So let's look at what this is doing. This is handling the case where we have something like 3 and 5 and then 2 coming in. So what happens is the second half, 2 is the smaller number. So it gets placed in and then 2 gets incremented. What happens is we're done analyzing this array. Then we can just place in 3 and 5. But what occurs here is that once we are done with our second half of the array, which in this case, what occurs is that our current index was only 1, so then he's no longer less than the length. We actually now have to have another while loop for our first half and our second half to just fill in the remainder. So while our current index for our first is less than our first half dot length, populate the remainder of your array. So we can take this code right here. So that handles one case, but if the second half is bigger than the first half, we need to do that as well. So while current index second half dot length, we'll copy this code. So now let's call merge in our merge sort algorithm. So merge first half, second half, and our array. And let's see if our code works. So we need to call merge sort in our main method. Go down to our main and let's call merge sort, passing in the array we declared, and run our code. There we go. Our array is sorted. So now we have written merge sort, but it is not written with multi-threading. So what is actually occurring, we're going to go back to our image. So what is actually occurring is we're splitting up the first half, and then with this code, we haven't actually looked at the second half yet. So we split up the first half and the second half, and then we split up this half, and then we split up this half. Then we merge them together, and then merge. But all this can be done in separate threads that can run concurrently, and we can utilize more than one core on our computer. So let's learn how to implement this with parallel programming. So going back to our project, I'm going to make a new Java class. This is going to be called parallel merge sort. We are going to implement merge sort using the fork join framework. And we're going to be using something called a recursive action. A recursive action is one of the two subclasses of a fork join task, and a recursive action doesn't return a value. The other subclass of the fork join task is a recursive task, and that returns a value. So let's write our main method. And let's take our main method from our merge sort, where we just defined a simple array. So we're going to write a method that kicks off our parallel merge sort. So right now I'm just writing a comment here that says call parallel merge sort. And let's define that method. So public static void parallel merge sort, and it passes in our array. So int array, looking very similar to our original implementation where we called merge sort that did the task. But in this case, we are going to make something called a sort task that extends a recursive action, and then create a fork join pool where we invoke that sort task. So we're going to make an inner class called sort task that extends a recursive action. So private static class sort task extends recursive action. We're importing in the Java util recursive action. And so this is yelling at us because it needs to implement the abstract method compute, which is what is invoked when you start the sort task. So our sort task is going to look very similarly to our merge sort method that we did previously. So in this case, we need to be passing in an array. So we need to make a constructor for our sort task. So public sort task, which now will pass in the array. So int array. And we need to set our array. So we're going to use a class variable to hold the array that we are trying to sort. So private int bracket array. And what our constructor will do is do this dot array equals array. And that sets the array that we're passing into for the new array that we are planning to sort. So let's go back to our code from our merge sort. And let's go to the merge sort method we created. We were looking at the array's length, and if it was greater than that 1, we wanted to split it up. Let's steal this code. So let's take this, copy, and paste. So all this code is valid except for when we call our merge sort and our merge. When we want to now do a recursive call to merge sort, we need to be calling sort task. So let's rename this to be sort task first half task, which equals a new sort task passing in our first half. And this will become sort task second half task, which takes in a new sort task passing in the second half array. Now we need for these tasks to be invoked. So invoke all, and we pass in our sort tasks. So first half task and second half task. What will happen is that when we do invoke all, it's going to invoke these tasks and call the compute method. So the next thing we need to do is call our merge. So we just need to access our merge sort class. So we've already defined here's merge function. Merge sort dot merge. And now we are calling that merge method. Everything works as intended. So let's go back to our parallel merge sort and make it actually call the sort task method and kick off the start of our merge sort. So this will be the initial sort task. So sort task, we'll call this main task equals new sort task, and it passes in the array that we want to sort. Then we create a fork join pool. So fork join pool equals new fork join pool. And finally, we have to invoke all the tasks that are added to this pool. So pool dot invoke main task. So when this main task spins up the additional tasks, they all are part of the same fork join pool, and it won't consider itself complete until all the tasks are complete. So let's go back to our main method and let's call parallel merge sort and see if our array gets sorted. So parallel merge sort array. I'm going to go back to our main method from our merge sort, and I'm going to take our outprint. So let's test our code. Right click, run. And there we are. Our array is sorted, and this used parallel computing. So maybe you're curious to see, is this more efficient? Well, let's find out if this is more efficient. I'm going to do long start time equals system dot current time in milliseconds before we call parallel merge sort. And then after we call parallel merge sort, I'm going to do long end time equals system dot current time in milliseconds. And let's find out how long it took. So system.out.println, and then we'll write total computation time end time minus start time milliseconds. So this will be how long it took for our parallel merge sort. Let's also call for this, we'll just make it the same unsorted array. So int, we'll call this array 2, and use our normal merge sort and see how long it took. So after this, I'm going to call merge sort dot merge sort passes array 2. And we need to get the total computation time for that. So I'm going to copy this code, get rid of our long. So we're not declaring the variable, we're just updating the variable's value. And now let's run our code and see what the total computation time was. So actually you can see that our parallel computing is taking a longer amount of time. And that's because our array is so small that actually spinning up these threads is a waste of time. So let's now make our arrays really big. So what I'm going to do is change our array to hold a large amount of numbers. So let's say this is new int, and it will hold 1,000,000 integers. And the same idea for our array number 2. And let's populate our arrays with random numbers. So for int I equaling 0, I is less than array dot length, I plus plus, and then we'll say array at I equals array 2 at I, which equals int math dot random times 1,000,000. So we're setting array at position I and array 2 at position I to a random number between 0 and 1,000,000. Well, 1 less than 1,000,000. And before we check how efficient they are, let's get rid of our sort outprint, because it's going to outprint 1,000,000 records. And now let's see how efficient they are. Still, our parallel sort isn't actually that much more efficient. But as we increase the amount of integers in our array, this will slowly end up being a better computation time than our standard merge sort without multi-threading. So if we bring this up to maybe 7,000,000 and we run, now you can see that our multi-threading is starting to be better. So keep that in mind. Multi-threading improves the speed for your sorts, but not when the list is small. So it has to be a very large number, and then you start seeing that improvement. So now you've learned how to do merge sort in Java using doing it in a non-parallel way, but also a parallel way.